Hey there, hackers! Welcome to another episode of Tacit Sanctuary. Today, we'll explore a real business problem by implementing the Luhn algorithm. This is a check-digit formula for numeric data. For example, it is actually used for the validation of credit card numbers, social security numbers, national IDs in various countries. Again, I have got the project idea from the Exorcism Challenge, and I really recommend to check out their video. They present several approaches to tackle this, and I will use some of those ideas for my Uiua implementation here. A real quick overview of what we need to do to determine if the data is valid or not. Given a string that may contain numeric digits and additional white spaces anywhere. Any other character is an error. We need to ignore the white spaces. Less than 2 digits is also an error. We take every second digit starting from the right side. Multiply these digits by 2. If the result is greater than 9, then subtract 9. This way, we always end up with a single digit. For example, the original digit was 6, then multiplied by 2, the result is 12, minus 9 is 3. Finally, add all these numbers and also the other digits that we did not change. If the sum is divisible by 10, then according to the Luhn formula, the number is valid. Let's see how to code this in Uiua. First of all, I will begin with a decent example. I will leave the nasty error handling part for later. I am starting with a string that is a valid credit card. First step is to remove the spaces. I can do this with the keep function, marking all non-white space characters. The number of digits can be odd or even, but always at least 2. In either case, I need to start counting the digits from the end, so I use reverse. I can convert all characters to numeric digits, using each parse. For now, I am just going to assume there will be no letters, but I'll deal with that case too later. Okay, now I have to do this magic operation on every second digit. Multiply by 2, and if the result has 2 digits, then subtract 9. Actually, I can do this formula to every digit. Only for the first part of each pair, I only have to multiply by 1. Then they will end up being the same number. So what I want to do is create a sequence of alternating 1s and 2s, exactly the same length as my numbers. To do this, I duplicate the array, then take the length, create a range from it, calculate modulus 2 of each number, and finally add 1. Now if I just multiply these two arrays, Uiua will do this pairwise, because they are the same shape, so it's like zipping them with the multiplication in other language. So far it looks good. Now the remaining operation is subtracting 9, wherever we have a 2-digit number. There is a trick here we can use. Any 2-digit number will definitely be smaller than 20. So it is easy to prove that the number minus 9 is exactly the same as adding the digits of the number. For example, 12 minus 9 is 3, and also 1 plus 2 is 3. I want to do this to each number. Unparse to convert it to a string. I end up with an array of strings. Temporarily, I can box these arrays because they have different lengths, just to see the intermediate results. Now then, I subtract the 0 character from every string, ending up with an array of digits in place of the string. To sum the digits, I will just use reduce plus. I can also remove the boxing now, because now the shape of my data is not jagged. Now, what's left is adding all the numbers with the reduce plus and checking if the result is divisible by 10. When modulus 10 is equal to 0, then the number was valid according to the Luhn formula. So let me rearrange the code a little bit. I assign the whole thing to the Luhn function, but the internal part, where I transform the array of numeric digits, I am extracting to a separate function d. My implementation is not complete yet without thinking about the edge cases. One trivial thing is that if I have any invalid character, the parsing will blow up with an error. One way to avoid it is using try. This can get quite complicated to use, but I will only use the simplest form. Try is a dyadic modifier. It takes two functions. If the first function causes an error, the second handler function is executed with the original arguments of the first one. In this case, I will just use the constant 0 as the handler to indicate an invalid result if the number cannot be parsed. I am enclosing all the remaining operations after the parse inside the try block. There is one more case that's not handled yet, when the data has less than 2 digits. I can solve this by adding an assertion inside the try block. Assert is a function that takes two arguments. The first one is an error message, the second one is the test value. If the test value is 1, assert has no output. But if it's anything else, then the error is raised. For example, I can check if a string has at least two elements by taking length greater than 1. This is my test. If it's not true, I want assert to throw an error. I don't care about the actual error message, so I just duplicate the test value. I can see that it outputs nothing for a 2-character string, but I get an error for 0 or 1 character. Note that the assertion used up the original value and the test result in either case. Removed it from the stack, so when I insert it inside my try block, I need to make sure to duplicate the data before I apply the assertion. In case of error, the try will capture the error even before processing the digits, so the validation result will end up 0 just the same. I can now test my Luhn function with single-digit string. I do have a complete solution now, but let's say I want to explore some alternatives to implement this formula. In my second attempt, I will take advantage of some unique behavior of Uiua, how it can pervasively execute operations on different arrays. It's a good thing that my code is already organized in a way that the function d can be replaced anytime. For development purpose, I will just reuse the first part to parse the digits before d gets applied. So my starting point is an array of numeric digits. So another way to think about this problem is rearranging the numbers so we can work only with half of them at a time. I want to organize the digits in 2 rows, each row containing the odd and the even positions. I can do this with reshape, giving an unspecified number of rows with infinity and 2 columns. Also, I want to use a fill character because I don't want to lose any digits if my array has an odd number of elements. Filling 0 in this case is okay because it will not affect the result either way. Then I transpose the result, so I have 2 rows instead of 2 columns. So let's check how it works with the odd array too. Now I want to leave the first row alone and do the magic to the second row only. For my second approach, it will be enough if I can multiply the second row by 2. The easy way is just to multiply this with an array of 1 and 2. These shapes are compatible because both operands have 2 major rows, and each value of my reorganized digits will be paired with the appropriate multiplier. Then I am going to D-shape this, because I don't care anymore about the order of the digits. Again, according to the formula, I need to examine each number, and if it is greater than 9, I have to subtract 9. So let me make a copy with duplicate and do the comparison. Now I have 2 arrays of the same size, and the second array has the 1 or true value in the positions where the first array has 2-digit numbers. Because the result of the Boolean operation is actually a number, I can now add these 2 arrays. What does that give me? The 2-digit numbers are now incremented by 1. and all I have to do is just look at the last digits with modulus 10. So again, I reach the same result as with my first function. So I can save this as db for an alternative to processing the digits. Let me change the original function name to da. And I also turn the Luhn function to a macro, which will accept the d function and use it at the placeholder position. So I can easily alternate between the two variants. If I carefully consider my db function, I can even remove the modulus from the last operation, because I also do that in the Luhn function anyway. After all, I only care about the last digits of each number. Also, I can use a fork to test both variants at the same time. So in the end, I think I like the second one better because it uses some really cool array features. But I guess both of them are a little difficult to comprehend if you just look at them and try to figure out what they are supposed to do. So in my opinion, adding a few comments or links to the algorithm description would be useful in an actual code base, so that tomorrow I will remember why I wrote the code this particular way. There could be other perfectly valid approaches. For example, I could have used structural under to work with part of the array, or I could have used a fold or a do loop to process all digits one by one. Let me know if you like these implementations or if you have an even better idea. Thank you for watching so far. I hope you enjoyed this. In that case, don't forget to give me a thumbs up. In the meantime, Uiua is also constantly improving and gaining features, and for me, it is really fun to explore how to write code with it in very unusual and amazing ways. I have more plans in the pipeline, so if you don't want to miss future episodes, make sure to subscribe as well. See you next time!